who is here today from Mills College. She is a Distinguished Research Fellow and the Director of the Lesson Study Group at Mills, which conducts research on this traditionally Japanese practice of doing lesson study and working with teachers. So other notable things about her is that she has a PhD from Stanford and is fluent in Japanese, which is very impressive. So, okay, over to you.
And I apologize for the slow start. When people ask me if I suffer from empty nest syndrome with both my children grown up and gone away, I always say no, but I suffer from a severe lack of technical support. I think I'm going to have to crowdsource when I have to switch over to the video, because there's something very strange going on with the hookup. Okay, so this problem, can I just get a show of hands of who's participated in lesson study in the group? Okay, a few people. I think actually there's some of Jake's colleagues' work in this presentation. So I'm going to show you in a little bit just a snippet of video of U.S. teachers taking part in lesson study. How many of you have seen the video, How Many Seats? Just 1 or 2, 3, 1, 2, 3. Okay, so I will use that as I planned in. So take a moment to look at this problem and think about how you would describe, how you would find this for any case. And also think about how fifth graders might solve it and what you would want them to learn from solving this problem. I usually spend a little bit of time having people actually solve this and discuss with partners, but I think I've just squandered your time to do that. So, but do we have any ideas about what you might want students to learn from solving this problem, or how they might solve it, what they might do to solve it? Yeah?
Well, you might want them to map out a set of cases so they can put it in a table.
So make a table? What would that table look like?
How many desk triangles and how many people.
Mm-hmm.
So
Okay.
look at a functional relationship.
Great. So they could create a table, and that would be one way to organize the data. Any other ideas about what you would want students to learn from this, or how they might try and solve it? Yeah.
Something like when you add a triangle or add a table, you lose a place for a seat, and you're sort of aware of that, and maybe you pick up 2 seats
Yeah.
and see if how that goes.
Yeah. So there's that strange thing where you add a triangle, but because you lose a seat, you only net 1, which is a very surprising pattern. Okay. So even in this problem, which appeared in the Navigations, NCTM Navigations textbook about a decade ago, there's quite a bit to explore within the mathematics of the problem. Okay. So, tell you a little shaggy dog story about how I got interested in lesson study. I was sitting in Japanese classrooms for months on end in 1995, and my research had nothing to do with math or science instruction. I was interested in children's classroom management and how they take responsibility for managing the classroom. And upholding the rules without a lot of authority from teachers. And all of a sudden, I was noticing all sorts of interesting things about mathematics and science because of the way the children who were studying it were doing it. So for example, I noticed suddenly that there were levers everywhere. And when I was pulling my train station, my rollerboard to the train station, that where I attached my heavy computer was a problem in levers. And likewise, I was trying to swing my arms when I was power walking, and I had a short umbrella in one of my arms, and I realized I couldn't swing them at the same pace. And I realized that was because it was a pendulum's problem. I was making one of my arms longer. And the same thing happened. I suddenly understood how pi had been discovered by people. And so I was getting this rich mathematics and science education from watching elementary classes. And so I began to ask Japanese teachers, how did you learn to teach this way? And they said, they sort of looked at me in great surprise and said, these teaching techniques came from the United States. And as I've done research in the ensuing years, often that's true. A lot of these teaching techniques came from model programs in the United States, NSF funded or programs, but they've never spread widely in the United States. But in Japan, because there's lesson study, they'll find these interesting curricula and programs from abroad and take them and then systematically study them, and teachers will spread them. So teachers said, oh, we learned this in lesson study. So I said, well, show me lesson study. So lesson study is a translation of two Japanese words, jugyo, which really means instruction, lessons, or lessons. So it doesn't mean a single lesson. And it definitely doesn't mean a lesson like, here's my lesson, something that's on paper. It's live instruction. And kenkyu, which is research or study, but it's definitely not study like study spelling words. It's study like study the situation in the Middle East. So the translation lesson study is a little problematic, and actually I had originally translated it in the mid-1990s as lesson research, but then when the teaching gap came out in 1999, they used the term lesson study, so I went with that and had a lot of recognition. So lesson study is a cyclical process. The first part of the cycle is to study the curriculum and standards, consider your long-term goals for student development. The second part is to plan a research lesson that will bring to life your ideas about how to teach a particular subject. Then you conduct the research lesson, one team member teaches it, the rest of the team members carefully observe students and collect data on them. And then the fourth part is reflection. You share the data that you've collected during the live lesson, perhaps also over the unit, and you reflect on what was learned about student learning, what are the implications, not just for this lesson, but for our teaching more broadly. What new learnings and questions do we want to carry forward into our work? And the central part of that is the research lesson. So what's a research lesson? It's an actual classroom lesson with students watched by other teachers. We'll see a little snippet on video. It's planned often collaboratively by anticipating student thinking and also by studying what's known about the teaching of that subject matter. And it's not just a lesson, it brings to life a larger vision or goal of education. So it's kind of a window on your larger instructional vision. And it's usually recorded in multiple ways so you can study it afterwards. And it's discussed by school faculty and sometimes by outside commentators as well. Okay, so again, we're not going to take a lot of time to do this, but I'll just give you a flavor of what the beginning of the lesson study process is. Typically, you think about the students at your school. So if you have some students you can call to mind, your students or students you've taught recently, or your children's classrooms, think about those students and think about all the qualities that you'd like them to have at the end of their current schooling experience, so at the end of elementary school or at the end of middle school. What are all those things that if your students develop those qualities, you would say, yes, we've really succeeded as educators. So take a moment to think about those. So typically, teachers would do this in a faculty meeting, and they'd make a list of all those ideal qualities they want students to have by the end of their education. And then think about a second list. What are their qualities now? What are the things, the characteristics that they bring to the table right now? What are the things that are wonderful and inspiring? What are the things that worry you or maybe drive you crazy? And then what's a gap between that ideal and actual that really motivates you as an educator? Something you'd really like to focus on. And typically schools choose a research theme that's this gap that they want to focus on. And they use that research theme for 1 or more years to guide their lesson study activity. So the example we're going to be looking at is a little bit contrived because it was just teachers who were in a summer workshop together in San Mateo, and so they didn't have a school-wide research theme, but they still built a research theme for their summertime work, which was to build children's curiosity and their ability to notice and represent mathematical patterns. It was at the time when algebra was being pushed down to lower grades in California, and so they wanted to think as elementary teachers, what could they do to build their students' success when they later got to algebra? So that was what they were focused on. And they picked this, how many seats problem was the context they gave it. They picked this problem out of the NCTM textbook. And the new textbook that was supposed to be sort of a reform-based textbook. And interestingly, the textbook, you can see here, they had a discussion, we'll see part of this discussion, about, you can see the +2 pattern, that's 2 more seats than tables, or 2 more places for people than triangular desks. And they had a long discussion about this +2 pattern, because they couldn't quite figure out how this +2 pattern fit with the fact that you were adding a triangle. Interestingly, this table, this is reproduced version, but was in the navigations textbook. So because it was in the textbook, they used it in their first lesson. They taught it sort of as it was designed in the textbook. Okay, so when we watch the video, it might be interesting to think about what affordances for learning are provided by each part of the cycle. We'll just see little snippets of their planning, the lesson, and post-lesson discussion. And also what kinds of protocols and routines support students or support teachers learning during this. Okay, so let's see if I'm going to be able to put on the video. If not, I feel like I'm in the right crowd to get help. Yikes. Okay, I need someone to help. Really, let's do this. So it should be there. It was in V. It's this, whatever that is. There it is. Great. So since I didn't watch how you did that, can I invite you up to do the same thing when I'm finished? Thank you. Thanks very much. Okay, so do you want to go to full screen? Yeah. No? Will we be bothered by the fact that it's not full screen? Will we be bothered? Yeah, okay. So these teachers, most of them are from a single school, but they were in a summer workshop where they studied sort of the elementary basis of algebra, and then that was the first week, and then the second week they did revise.
I thought when we added a triangle, we were adding 2. But the output chart here is adding 1.
So she's going down that table.
And
I just counted them.
I don't understand why that is, because what you showed.
Because the third combined one.
Let's do this way.
Oh,
So maybe it would be a good time to
Wait a
have us
second.
do the activity. Yeah, maybe. Because if you have one triangle, you have 3.
you have
Then
1
you have
triangle, you have
2.
3.
One of those 3 becomes a combined.
You're not counting.
You
Two
share. You share.
2 of them become combined. That's why we don't have 5. Because I'm thinking, how come I don't have 3 plus 2?
So you
I
don't
just
count the
did the
shared
same
side,
thing.
right? Is that what it is? You don't count the shared side.
It's the number of triangles plus 2.
Yeah, I was very good way I did that.
But a lot of kids
Here's
would
the number of
count
triangles, and then here's the plus 2 goes this way. So that's one of the things,
Now,
the
why
aha
is
that
that?
people had yesterday was, when kids look at patterns, we look this way instead of looking the across
That's
way.
what I was just doing, that's what
Yeah.
happened to say,
Right, you were looking the down way instead of seeing the patterns also going this way.
I'm
So are
still-
there enough triangles here for people to try to, yeah, do it themselves and keep adding triangles and create your own chart just to kind of
Everybody want to do that?
see how it will feel for kids?
Us, we have enough. I'm still, why isn't it, if I add a triangle,
You're only counting the outside. You're not counting.
why am I not 3? So there's the 2.
So what you,
Okay, students will discover a pattern.
so what you notice about what they were doing, how that was similar or different from planning, familiar to you, for those of you who've been teachers? What did you see as the affordances for learning?
Yeah.
It's interesting. I felt like they didn't really get what she was puzzling over, and they were just reminding her of the answer that they already had. Like if we say it louder, she'll get it or something. Kind of like that +2 thing. I see a lot of +2-ness there, but they didn't. They're like, it's +1. Like trying to mind meld. Like, I'm going to give you this in my head. That's not what you asked, but I did notice that.
Yeah, no, that's, and I apologize, I'm really just showing you a snippet. They worked for about 2 days on this. And they did eventually, by the end, you can hear them clearly articulate 2 different problems in the pattern, but I think you're right at the point they were looking. They were struggling to understand what she was struggling with. What did you notice about sort of how this was similar or different from planning that's familiar? What might be the affordances for learning here?
They're not working backwards from the answer, they're actually finding the answer themselves.
Yeah. So that's kind of a cardinal rule of lesson study. You solve the problem yourselves, and you think about how would students solve it. What are the correct solutions? What are the incorrect solutions they would come up with? So they are doing this to anticipate student thinking. And then think about, well, if a student thought about it this way, what are the experiences that would lead them to move on? Yeah.
The conversation very much focuses on what students will do, what you do. It never focuses on this is what they'll learn. It's very much on the processes of what they're doing. There's definitely a shift rather than we're going to do a lesson that teaches this. It's we're doing this lesson, how are they going to be thinking about it?
Yeah, although they do talk at other times about what do we want students to get out of it, what do we want them to learn. But there's not, but there's definitely a focus on the student, the interaction between the lesson and the students' thinking, as opposed to, just laying out what's the activity and what do teachers do in the setting. Yeah.
Sorry, just at the beginning, did they have the table provided for them, or they decided to create it?
They chose the lesson that they wanted to work on. They looked at various sort of foundation for algebra lessons from various U.S. textbooks.
Yeah, but she started with the table.
They chose this one, and that was in the textbook.
Oh, in
that
the
table was in the
textbook, okay.
textbook, yeah. And
Did they expect the students would get the table immediately?
That's the way it was set up in the textbook, and that's the way they taught it the first time. And then it's
wouldn't go with
very,
that.
what's that?
I wouldn't go with that.
Yeah. That's what they learned too, yeah. I am not able to see I am really, let's see. So I need the other parts of the video. So this video it was like a chapter page to this video.
Find a pattern,
The
just
actual structure.
So it's all in this video in TS folder. This is just the chapter.
Yeah.
Yeah.
The tables are
A snippet of the first.
This is what I want you to discover, either by yourself or with your partner. What is the pattern? This is what I want you guys to do with your triangles. I want you to fill out to here. Fill out how many seats with 3, how many seats with 4, with 5, and with 6. Now when you're done with 6, stop and really look at what patterns do you see on this chart and with your triangles, all right? And then write about them down here. Any questions? Okay, let's go ahead and get started.
That's it.
done writing about the pattern, would you turn to the person sitting next to you and kind of talk if they're ready to listen? And share what, see if you guys agree with what you've discovered?
So this is what I got, like, every time you go down, like 3, okay, 1 plus what equals 2, so each time you have to add, like, 2. One pattern is that for the output is 2 more than the input. It's kind of easy. Because once you get that, is you know the whole thing.
Okay, so the number of tables plus 2, okay, equals what? Number of tables plus 2, that is what? What are you trying to figure out?
So 5 kids raised their
What are you trying to
hands
figure out?
this way, and the one
I'm
who
not
called
seeing
on
any
was wrong.
hands up.
Start with X's and we'll show me how you did it.
I put one, I counted this one
Uh-huh.
and this side that equal 2 plus these 2 and that equals 4. And then I counted the rest of these. And then I got 12.
All right, did anyone have a different way to count it than that? More? This is fascinating. All right, show me what you got.
First I counted this one.
Uh-huh.
And this one.
Okay.
Then I counted this one, 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 this one.
Okay, I'm going to give you a little strip. Each and every one of you is going to have one. It's going to have a table, and then here you are going to have to figure out how many seats will fit around that table.
There's 5 tables. 5 tables. There's 5 tables. Look, if I put it like this, look, it's 1, 2, 3, 4, 5, 6, 7. Our pattern is this is the pattern. There's only however many tables there are, there goes 2 more seats. Every table gets 1 seat, except for the top and bottom. Every table gets 1 seat. Seat 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. Number 2. Wants to write it. EX. Except the sides.
Just going to, again, play a snippet of the debrief after
Did
the
students
first
make
lesson
a
that
connection
led to
that a pattern
design.
builds a rule?
At the very end, when I was trying to get them to say the number of tables plus 2 equals the number of seats, there was a lot of confusion. It's easy for them to just go plus 2 plus 2 plus 2. And they sort of lose the whole picture of what is the plus 2 representing.
I noticed kids counting the seats different ways, and this was kind of a big aha for me when I realized that some of them weren't seeing the pattern really, they were just adding 2, and that some of them were really seeing it differently when I was actually watching them and the way they counted them. So Jessie was counting, 1, 2, 3 around like this, and when I've done the problem myself, that's always how I counted them. So it didn't occur to me that there was another way to look at it. And then Alyssa was counting 1, 2, 3, 4, 5 like this. And I thought she had 20 triangles out. So she's counted essentially, there's 10, you could then it looked totally different to me. I could see, oh, there's 10 triangles on the top, there's 10 triangles on the bottom, and then there's a seat on either end. So now I was seeing the pattern a different way.
Well, I'm just wondering now after the comments, I'm thinking, why did we do 1, 2, 3, 4, why did we do this pattern like that? I mean, I know for myself it was in there. Right. So that's a good lesson for us, I think, always to really question, just because it's already done for you, is it really the most effective use? And I'm thinking, how would the lesson have been changed if we had started off with, 10 and then 17 and then, just these random numbers? Then you would not have had, there would have been no vertical pattern. It's kind of fun to think about all the different things you can kind of tweak and then look and watch and see what they do. Gee, I guess that's called lesson study.
I think so.
Okay, so. Any questions while we're getting this up? I'm going to skip ahead of talking about the affordances of that so that we can get a sense of what's happened in lesson study. Since I said I was going to do 14 years of research, which a colleague made fun of me for, I do want to move forward. Okay, so we saw some of the snippets of each part of the process. I'm curious, how many of you had the experience of seeing a program adopted and not really taken deeply, and then before you've had a chance to really make it work well, take hold, it's been discarded and you've moved on to something else? Has anybody had that experience? Okay, so I think one of the reasons this happens is that people glom onto the surface features of programs. Over on the left, the sort of visible features of lesson study are the things like planning, conducting a research lesson, etc. But they don't really think about what are these surface features trying to accomplish, what's supposed to be happening. And I think to some extent that happened with lesson study, and a lot of my work has been designed to try and help people think about how lesson study works so that that won't happen with lesson study. So one early misconception about lesson study was that it was about polishing a lesson, sort of making a perfect lesson plan. Obviously these teachers improved the lesson plan by getting rid of that table that was in the textbook from lesson 1 to lesson 2, and also giving each student a different number of tables and having them show their counting methods so kids could get insights into the geometry. But it wasn't just about improving the lesson plan. It was also about really learning to carefully notice students' thinking, doing the math themselves to understand the math in the first part, getting the sense that by working together they could learn from colleagues. So there are lots of elements. So I think there are these basic 4 sort of buckets of activity that are, or impact, that are the pathways by which lesson study improves instruction. Okay, in Japan, lesson study is used typically to implement new contents, new subject areas, new instructional approaches. And for example, when I lived in Japan in the 1990s, they were adding solar energy to the elementary curriculum. Solar energy had never been taught in Japanese schools. So they started by, the government put out funding for, I think it was a couple hundred schools that wanted to serve as sort of pilot schools to research solar energy before it was required 2 years later. Those schools used a lesson study process. They consulted with academics. They tried different approaches, studied their students extensively, and then after about a year of experimentation, they began to open up their schools to do research lessons on solar energy. So you could go to lots of areas in Japan and see schools do research lessons on solar energy. And knowledge quickly spread about all sorts of aspects of it. What was important about solar energy, how you taught it, from the very practical to the very academic. And this is a conversation that I recorded at one of these. A teacher was observing a public research lesson, and she asked about 3 student strategies she saw. They told students to increase the energy of the solar cell, and students tried 3 things. They moved a lamp closer to the solar cell, they added a second lamp, and they used a magnifying glass to concentrate the energy from the lamp. These were all ideas the students came up with. And so the teacher said, I want to know whether the 3 conditions the children described, those 3 conditions, would all be considered the same thing by scientists. They don't seem the same to me, but I want to ask the teachers who know science, whether scientists would regard them as the same thing. So there were both secondary science teachers and also university-based science faculty attending these research lessons, so you could get an answer to your content questions. Okay. And so lesson study in Japan is, there are networks that involve not just K-12 schools, but also university-based demonstration schools, university-based educators. Okay. People are reporting tremendous practice of lesson study in the United States, as you can see here. Although I have to say, I wonder what they mean by lesson study when they're reporting these kinds of figures of 50%, we don't really know. So I want to summarize quickly what I think we've learned about lesson study in the last 15 years or so. The first thing I think we've learned is that you need good curriculum materials for teachers to study during the first phase of lesson study. So that study phase is really important. Give you an example of what I mean. This is the first lesson from the Japanese textbook introducing area of rectangles to third graders. And they have these newsletters, which are the sort of white space at the center, class newsletters. And then they're surrounded by students' drawing papers, and the students are saying, which class newsletter is bigger? What if we put drawing papers on top of each newsletter? Let's think about a way to compare and express the size of these shapes. So that's a Japanese lesson. This is introductory lesson on rectangle area from Hartford Brace. You can see the rectangle is already divided up into squares. They've given students the square units. This is what the Japanese Teacher's Edition says about the introduction to area, including to promote taking these steps, a rectangle and square without grids are used, so they explain the instructional choice. All the US Teacher's Edition says is the area is the number of square units needed to cover a surface. So you can understand why when I watch American teachers doing lesson study and using their own Teacher's Edition to do the first phase of lesson study, they weren't learning very much. So I started translating some of the Japanese Teacher's Editions for US teachers to use in the lesson study. So you can see anticipation of varied student thinking comprises 28% of the statements in the Japanese Teacher's Edition for these chapters on area of polygons. Only 1% of the statements in the US Teacher's Edition. So you're getting a very different experience using the Japanese Teacher's Edition. Likewise, single correct student answer is 3% of the Japanese Teacher's Edition, 13% of US Teacher's Edition. Okay, what else have we learned about lesson study in the US? School-wide lesson study can improve student achievement, but it's very rare. Not many schools in the US are doing school-wide lesson study. And we're trying currently to build it in some research funded by the Gates Foundation in several schools in each of 3 districts, Oakland, San Francisco, and Chicago. It's hard going. I welcome collaborators, anyone who's interested in talking about it. This is from a school-wide lesson study school in San Mateo. You can see there, this was just selected lesson study groups at the school, but from year 1 to year 3 of their school-wide lesson study effort, the percentage of statements focused on student thinking went from a much smaller number to a much larger number over 3 years, both during the planning meetings and during the post-lesson discussions. And similarly, there was a great decrease in the percentage of statements devoted to a fixed evaluation of students, like that's a slow student, that's a fast student. So instead of using those kind of global characterizations, they were talking about what particular students are thinking about particular problems. That school had about an increase in its mathematics achievement. It was about 3 times that in the district as a whole. You can see the blue is the school, the red is the district, and the yellow is the state for that period. Okay, third thing that I think we've learned about lesson study in the United States, that locally managed lesson studies supported by mathematical resource kits can improve both students' and teachers' mathematical knowledge. We mailed out resource kits for lesson study to teams of teachers across the United States. There was about a 3-month intervention period, and if you're an experimental psychologist, you're not going to like these conditions, I can tell you, because this work has been really criticized by the reviewers, who I am assuming to be experimental psychologists like I am. But one of the conditions received the resource kit, and the resource kit included guidance, and they run lesson study, and they conducted a lesson study cycle. Another condition conducted lesson study, but it wasn't on fractions, and they didn't receive a resource kit, and I included that because I wanted to include a condition that's like lesson study in the United States, where teachers are not told what to focus on or told what resources they have to use, because I felt I wanted to know whether we were undermining teachers' intrinsic enjoyment of lesson study and their sense of, this was high quality professional learning. And then the other was sort of a business as usual condition. They also were not told that they had to improve their fractions instruction. But everyone was quite aware it was a fractions study. They tested their students as well as taking the fractions assessment themselves at the beginning of the study. So here are the sample characteristics. So the resource kit focused on what are the challenges in seeing fractions, as in understanding fractions for students. And it basically looked at 4 sets of challenges. And it did this by giving teachers math problems to solve, for example, from NAEP or from other things where there are data available. And then the question of, well, think about why do, I think it's more than half of 8th graders, they're not able to figure out the 12/13 plus 7/8, I'm not remembering the exact problem, is about to on a NAEP assessment. It's a multiple choice test. So they sort of investigated and inquired into these challenges in understanding fractions. Then we invited them to think about what different models of fractions might afford for students' understanding of fractions. They read summaries of some of the research, including Jeff's research on using a linear model for understanding fractions. And then they received curriculum materials from the Japanese textbook and also a fractions video instruction of 3 introductory lessons on fractions, a series of lessons taught by a really experienced Japanese teacher to US children. So the Japanese textbook introduces fractions by saying we have this strip that's a little bit longer than a meter, this little bit longer piece. How do we describe that in terms of a meter? So how do we describe that mystery piece in terms of a meter? And they discover by doing the activity that it fits in 3 times. Oh, that's a third. So we asked teachers to think about what are the affordances of that versus, say, a set model or circle area model. So I'm going to skip through a little bit of this because it's mainly rationale for why we chose that model. So teachers engaged in this lesson study process, and they were given both support for the lesson study process and curriculum materials, mathematical resources. But it's interesting that these were all just mailed out. We had no personal contact with these sites. So they took an assessment, then they were assigned a condition. The materials were mailed out, they took a post-assessment and mailed back their video of their meetings and their assessments to us. There we go. Okay, so basically the materials help them, particularly in the first 2 phases of studying the curriculum and planning the research lesson. Here you see teachers, they had their own mystery strip task, which was much more challenging. It was 2/7. So here's a mystery strip, here's a meter long length, not ruled. Tell us how long this mystery strip is in terms of a meter. And it was very hard for the teachers to figure this out. But they had gave them a very powerful understanding of the importance of seeing that 2/7 is 2/1/7. And here are the same teachers watching their students solve the task during the research lesson. So we looked at teachers' knowledge of fractions using largely LMT items, students' knowledge of fractions, and some survey scales on teachers' beliefs and dispositions. Here are some examples of student items. We also asked teachers to rate the quality of their professional learning on these 11 items that were from Horizon research. So we're very interested in not undermining this sort of inquiry sense of lesson study. This is interesting. This is the only comparison we did between the 2 where we broke down the control conditions. So in either lesson study condition, teachers had a high rating of the quality of their professional learning. In the control condition, in which ironically they chose their own professional learning methods, so they chose all sorts of things. Some chose to go to an NCTM conference or to have a coach or whatever they wanted to do. But they didn't regard that as highly as they regarded the lesson study. We used HLM because the students were nested within teachers, which were nested, the teams were nested within conditions. And looked at the various outcome measures, and all three of the major outcome measures. Teachers' own fraction knowledge, the perceived effectiveness of collegial learning, which is items like it's very useful to solve mathematics problems with my colleagues. I've learned a lot about student thinking from my colleagues. And expectation for students' achievement, which is the McLaughlin and Talbert measure. It's items like, by changing my teaching methods, I can reach more students, or most students aren't capable of learning the material that I give them, that one reversed. So it had a significant impact on each of those, and also on students' fractions knowledge. So you can see here the experimental group in red, the control group in blue. Here's a comment from a teacher who wonders what her own understanding of fractions would be like if she'd been first introduced by the linear measurement model. This was teachers reflected on whatever they wanted to, but a lot of them reflected on the linear measurement model, which was new to virtually everyone, which is interesting. You can read here. One of the things I like about this quote is that it captures how there are elements of learning at each stage of the lesson study process. It's not simply about learning a sort of piece of math. It's about learning to observe. It's about having colleagues observe your instruction. It's about improving your collaborative relationships. It really is an intervention that has a lot of different elements to it. The What Works Clearinghouse, it's not actually the What Works Clearinghouse, it's a Gersten et al. What Works Clearinghouse criteria review. Probably some of you saw this. So they really privileged randomized control trials and quasi-experimental designs in their review, but this was one of only two studies that showed an impact on students' mathematical proficiency out of the 643 they reviewed. Okay, and finally, what we've learned is that U.S. teachers can use lesson study like their Japanese colleagues do to spread knowledge across a region. And I just want to not drop this because this, actually Jake Diston was involved in this. This is from a board illustration. Akiko Takahashi, who's a very experienced Japanese elementary educator and now a professor in the U.S., taught a lesson in San Mateo in which he asked students to make a 4x5 geoboard on or a rectangle on their geoboard. And then he said, oh, I see two kinds of drawings. Which one of these is 4x5? And he actually spent about 5 minutes having kids say, well, I think that one's 4x5 because I think that one's, what was this student thinking? What was this student thinking? And he said, well, that student was thinking, 4 dots by 4 poles, pegs by 5 poles. What do you mean pegs? Come up and circle the pegs. That one was thinking 4 squares by 5 squares. I don't see any squares. Where are there squares? Come up and show me the squares. So really engage them in a pretty extended discussion of what a 4x5 rectangle was, which is really interesting for me because some students continue to not understand that in middle school. So some observing teachers in the Silicon Valley Mathematics Network saw this and wanted to be able to slow down instruction that way in their classrooms, but they didn't feel confident in knowing what were the mathematical points ahead of time where they could slow it down or being able to have that conversation. So they invented something they called re-engagement lessons, where they would use work from the prior lesson that showed a kind of powerful misconception and use it to reintroduce the first lesson in the next lesson series. So this is actually from when Jake was teaching at Willard Middle School. They took this idea and applied it to proportional reasoning of beginning the lesson by showing a correct and incorrect way of thinking about increasing this picture to a poster size, and saying what was student A thinking, what was student B thinking, and then asking them to apply student A's way of thinking, which was additive, and student B's way of thinking, which was multiplicative, to a new problem of lemonade solutions. And the teachers in that classroom, when they did this re-engagement, said they had a better understanding of proportional reasoning than they'd ever had in their 8th grade classes. So this idea of re-engagement spread across at least 7 districts in this area, levels of schooling, subject areas, school foundation boundary. So in summary, we've learned that teachers value lesson study when it's supported by high-quality mathematical materials or other content materials. It can positively impact student and teacher mathematical knowledge, and it may build beliefs that nurture teachers' future improvement, and that teachers can use it to spread innovations across sites. But I think there's still some major elements missing in the United States. In Japan, public research lessons are really the proving ground. You wouldn't imagine that you could know whether a new curriculum or a new set of standards was working until you had tested it in this proving ground of public research lessons. Whereas I think in the United States, when we publish new curricular standards, we often think, oh, you know, all that work is done, you know, we can now move on. Implementation is a trivial problem. It's a really different way of thinking about improving education. And the Japanese basically believe that, you know, curriculum and standards are just kind of splotches of ink on paper until teachers learn to bring them to life, and you can share the knowledge of how to bring them to life. There are grants for designated research schools to do that work of bringing it to life. And there are broadly established school site learning routines, so that if, say, one teacher who's particularly interested in math goes from your school to watch a wonderful research lesson, they can come back and say, hey, let's try this in our lesson study. So you have these sort of interlocking networks of routines. And the curriculum itself is reshaped by lesson study. So Japanese educators were really startled when they saw that table in the NCTM textbook, because that table had been tried and eliminated early on in Japan. So textbooks actually come to reflect what teachers learn in lesson study, and that's really different. Here, I've got to skip through this. And just maybe use this as our last. I think one way of summarizing lesson study is that both Japanese and US teachers spend a lot of time and effort improving instruction. But down in the green, watching and discussing each other's classroom lessons, there's not so much time spent on that in the US, where there's a lot of time up in the gray area, choosing curriculum, writing curriculum, writing local standards. So in a sense, in the United States, we're spending a lot of our instructional improvement. In Japan, in the United States, we're trying to improve our instruction without spending a lot of time actually looking at and discussing instruction. So our instructional improvement effort rests on a very tippy base without much data of what's actually going on in the classrooms. Skip through again. There's one nice quote I will leave you on. So I think this again speaks to the multiple opportunities throughout the cycle to learn to observe students more closely, to work with your colleagues, to really take the initiative to be in charge of professional learning, indulging curiosity. And I do have, I'm happy to share the PowerPoint, and I do have in it all the references as well as an opportunity. If you know, the fractions lesson study randomized controlled trial was just funded for a larger trial. Jeff's on the advisory panel for that. And so if you know schools where teachers might be interested in conducting a fractions lesson study cycle next school year, it's a very nice study. It's a nice supported way to begin lesson study, and there's a stipend for schools that want to participate. So I'll leave it there, but I'm happy to share the resources and references. And I assume that leaving a half an hour for questions would be a good thing.
Could you go back to your slide with the,
Sure.
with the graph on the
Is that the student?
It was red and blue, maybe classrooms that were just given materials compared to.
Are you looking for student learning or teacher learning?
I think it was students in their performance. That one.
Yeah. There we go. Yeah.
I only saw the top of that graph originally, and I thought that was, I would have all, each pair was that same thing.
Yeah, no, I
And so I couldn't see it, but now I can, and now there's different questions, like what happened in grade 4?
Yeah.
That was different than grades 2 and 3, et cetera. What, why the different patterns in your sense?
I don't know, and it wasn't a huge, so there were 13 groups in the experimental condition, 26 in the control, and they were highly variable. I mean, they included, 100% free lunch eligible and 0% free lunch eligible. Very experienced teachers and not at all experienced teachers. So there's a lot of variability. My guess, if I had to give you a guess, would be, I don't know if that would explain it, actually. I was just going to say that all fourth graders may have had a recent fractions unit, because it tends to be a big grade 4 topic. I'm not sure that explains that.
What was the test? Was it a standard test or one that you had created?
It was a project-created test. These are Z-scores, so they're equated across grade levels. The test came from NAEP, California Standardized Tests, research studies, and curriculum materials. And it definitely tried to hit sort of two things. One was items that everyone would look at and say, yes, students should know that. So you saw some of those, like, which of the following of these fractions is the biggest, a half, a fifth, a seventh, a ninth, or which is bigger, 5/6 of a gallon or 1 gallon. But it also tried to think about if your mind was not able to deal with a linear measurement, linear model of fractions, what would be very hard to deal with. So some of the items were items like, which are very common in Japan but not so common here. How many 1/5 are there in 3/5? And you would think anyone who understood fractions would be able to answer that. And that item was, I think, it was a little bit differentially easier for the people who had been in the experimental condition, who had the linear model. Although, even when you took out all the items like that would not be familiar items to U.S. students, the effect size was still about 0.45. So there was definitely an effect size on how we measure fractions instruction. Yeah.
So actually, it looks like if you control for your pretest scores, the only grades that are showing much of anything are grades 2 and 3, because in grade 5, you've got a pretty nice difference up at pretest to start. So I guess I'm wondering there must be, kids seem like they're improving from pre to post regardless. In the earlier grades, you see a nice increase for the experimental group. Did you see anything, do we know anything about the teachers? Were the grades 2 and 3 teachers, really collaborative, really talking about things? Or did some of the other teachers go to different kinds of trainings that they really liked? Do we have any sort of insight in?
Actually, there was I don't have, sorry, I should have the data with me. I don't have the data. There was an increase at each of the grade levels.
Okay, yeah, it's
It's
from
obviously
here.
larger at grades 2 to 3.
From grades 2 to 3, but I
Yeah.
would be hard, I would like, well, it doesn't matter, but I wonder if there are any other sorts of, because lesson study, it seems like it comes with a lot. Right? You're asking a lot of the teachers to really engage with it. And so were there certain kinds of, practices or things that really lent itself to the benefits of lesson study?
We don't have a good handle. It's very hard to know. We've done some analyses looking at the 13 groups in the experimental condition, but they don't fall neatly into, I thought, well, they'll fall neatly into these groups really improved student achievement, these groups really didn't, or these groups really improved their own knowledge, these groups really didn't, or these groups really built their belief in the capacity of students to learn, these groups didn't. But it's all over the place. There are 3 to 8 individuals in each group. The story for each one of them is different. Only one of those individuals in the group taught the lesson. So the story for the individuals may not be the story for the children, although the teachers plan the instruction together. So it's very hard to know sort of where to go with those analyses, but the one thing I can say is that I've looked at a lot of the video. They self-video recorded their meetings, and they did definitely use the resource kits. So they solved the math problems and talked about what students would not understand about it. Often in solving those math problems and talking about that, it surfaced misunderstandings in the teacher's learning. So, for example, one teacher read a section in the resource kit that talked about fraction as number, and she said, a fraction's not necessarily a number. If you have 2 out of 3 hats are red, that's not a number. And then another teacher in the group said, well, it is a number because you could put it on a number line. So there were a lot of conversations like that, and those were different in each group because people had different misunderstandings. Another teacher, they were reading a problem that was something like, Jose argues that a third of his cookie is bigger than a half of John's cookie. Could Jose be right? Why or why not? And in the course of discussing that problem, one teacher in the group said, I don't see how that could be true. And then she said, oh, I get it. The cookies could be a different size. And then another teacher in that group said, in the textbooks, they always give our students like a third or a seventh, which is bigger, but they never say a third of a constant object, a seventh of the same constant object. So that's not really fair that our textbooks do that. Of course it's going to be priming kids for that. So they had a very extended conversation about that. So those conversations were really different. They were rich conversations in all the groups that I've watched, but they were different, different things. And in that sense, it's a kind of differentiated professional learning. If something's obvious to you when you read it in the resource kit or when you look at student solutions, you don't choose to discuss it with your peers. If it's not obvious to you, you raise a question. And also, some of the groups, about 7 of the 13, exactly 7 of the 13 groups, decided to just use the lessons that they saw on video taught by the Japanese instructor as their introduction to fractions. And actually, I could look at whether more of those were 2nd and 3rd grades. They might be because the kids hadn't been introduced to fractions previously. And so some of the conversations around whether to use those lessons or whether to try and reshape their own textbook to take into account what they learned about students' fractions were also differentiated the groups. And it was interesting, one teacher said, well, our kids won't be able to do that, what those kids are doing in the video. Another teacher in the group said, well, they might be able to. They might be able to discover that the mystery strip goes in 3 times. Well, I don't think our kids can do it. They're not like those kids in the video who were at a private school. Well, why don't we try it? It's only 45 minutes. Why don't we try it? And so you could see how the sort of sense of effort, and then when they reflected on it afterwards, they realized that all the kids had been able to sort of figure it out, So, yeah.
Yeah, so it seems like implementing these lessons requires a pretty high tolerance for ambiguity in the classroom for these teachers. And they're often not used to that, you're just used to like getting to the answer. Did you see that hindered them being able to do the lessons at the highest level? Or did you actually see that maybe a shift in teachers becoming more tolerant sort of ambiguity?
Yeah, that's a really interesting question. You know, I interviewed a Oakland history teacher who was about a fourth-year teacher, and he said that one of the things he'd chosen to do in lesson study was use role play in his classroom for the first time. He never felt comfortable using role play, but he thought, here I am in a lesson study group, it's not my lesson, it's our lesson. My colleagues are helping me plan it. If it flops, it's on all of us. So I think in some ways that ambiguity is, you know, when it's our lesson rather than my lesson, which is one of the things that, you know, you nurture through a good lesson study process, it makes it a lot easier to tolerate the ambiguity. I think what is, and also if you have all those eyes up front anticipating the student thinking and solution methods, you feel a little more protected. You know, you feel like, oh, we've thought about this that they might do, we've thought about this that they might do. And then if there's something they do you haven't thought of, again, it's on all of you. So I think there is it does support that tolerance of ambiguity.
I was wondering, because it seems like in Japan this is a long-term ongoing thing. So if you had the chance to follow up the schools that you've done lesson study with here, see if any of the things that you saw changed carry on or.
Oh, that's a really good question. So the school that's focused on in San Mateo, which is, it's public, your name is public, so I don't need to worry about it. Basically, the district really, the school loved lesson study, and from about the second year, when people came to the school, they would say, well, we do lesson study at this school, so if that doesn't interest you, don't come here. It became sort of the culture of the school. After about 6 years, and with a new superintendent, the district really disliked the lesson study. It sort of felt to them like they were doing something against district wishes. They wanted the school to be doing exactly the curriculum at exactly the pacing that was in the district plan and using lots of individualized technology rather than teachers sort of leading an inquiry about what's the best way to teach math. They particularly wanted them, I think, to use some kind of heavy-duty IT program. So basically and they really tried to humiliate the school, which was interesting, given their high achievement. And they managed to humiliate the school using political means. And by the end of that experience with the new superintendent, the principal left, all the most qualified teachers left. And it was interesting, they all got jobs in very good districts like Palo Alto, because they were very well trained through this process. They've all scattered. The person who was the principal has nurtured lesson study in her new school. So, you know, there haven't been that many cases of long-term, very similar thing with Patterson School No. 2 in Patterson, New Jersey, which was another really early adopter. You know, there's one district, I think, in the United States that's been doing lesson study for more than 6 years, and they've had a gradual build-up, and they've really shown, I mean, it's impressive to me how if you have school routines like being expected to explain your mathematics thinking or your thinking about reading and being expected to present evidence and to provide a mathematical expression to go with your thinking, if you build those in kindergarten, the job of the first grade teacher is much easier, and likewise, and so you can really spend a lot more time teaching than building routines. So in the few places that I know that have been continuing, those routines are incredibly impressive because teachers build and share their knowledge about how to do them. And that's basically how Japanese have developed, you know, teaching through problem solving, is that, you know, these routines have developed and spread and they're always being honed. And, you know, even compared to when I started going to Japanese schools 30 years ago, there are lots of routines that are now very commonplace that have been put into place over time, but then spread very widely. So to take one really easy to track example. 30 years ago, you never saw a Japanese classroom where kids' names were on magnetic strips on the board, because the boards are magnetic. Now, you never go into a classroom that doesn't have that. And a lot of them have these very cute things where kids have done pictures of themselves. And those came in the 90s when they were trying to figure out, well, you know, we want to have the teacher bringing in a lot of the sort of key mathematical or scientific or, you know, literary points, but we want all the kids to remain engaged in the instruction. So, for example, we'll ask kids, you know, which do they agree with? Is 2/3 of 2 meters of ribbon, is it 2/3 or is it 4/3? You know, which do you agree with? Which answer that your classmates came up with do you agree with? Put your marker here, and if you change your idea when the discussion's occurring, come up and move your marker and write in your notebook why your thinking changed. So the kids, you know, 40 kids in the class could see their thinking represented next to the idea that they agreed with and go up and shift it and be aware of when their thinking changed and write about it. So that's just like a really simple example of, you know, something that's spread widely in the time that I've been watching.
Thinking about other countries that perform well in mathematics that don't use lesson study, maybe, I don't know, Korea or Singapore, just, and so is this, in your view, is this what accounts for maybe Japan's performance on math tests? And then how would you contrast that with sort of similar performances or better performances in folks that don't use this at all? And I know there's different cultures, different systems, but I'm curious about what can be learned, what can be borrowed, and what just doesn't fit in, I'll say, our system. Whereas this seems like it could fit. It's a curriculum. People could, you know, the golden lessons could make their way to the U.S. and we all.
You know, I think a lot of the successful. I'm just editing writing a commentary for a ZPD special edition on lesson study around the world. And China and Korea do have some, I wouldn't call it lesson study, but they call it lessons, these English language articles call it lesson study. But it's a system of collaborative learning. It's a little more competitive than the Japanese version. It's about, you know, teaching a lesson in front of a lot of people and having it rated and having lesson competitions and so forth, which is a little different. But it's similar in its public presentation of teaching, public observation of what students are learning. Singapore, you know, I've spent time in Singapore classrooms and I was really interested and heartened recently. And Singapore has taken up lesson study very heavily in the last, I don't know, 8 years, 10 years, but it wasn't a traditional practice then. And I was really heartened recently when I was sitting around with a bunch of Singapore teachers and they all said, oh yeah, Singapore lessons aren't very good at all compared to Japanese lessons. And that's because that's how I've always felt being in their classrooms. I mean, it's like a very well-executed form of what you often see in U.S. classrooms as our ideal of, you know, I do, we do, you do, that kind of instruction. It's not, you know, Japanese do teaching through problem solving. It's a very different style of teaching. And it's really meant not simply to build mastery of the curriculum, but also to build problem-solving habits of mind. So to build, they were very influenced by Polia's work and by the 1980 Agenda for Action in the United States, and really used that to inform, to really shift their mathematics teaching from basically teaching as telling to teaching with understanding. And one really interesting slide that Akiko Takahashi presented recently shows the 2006 TIMSS results arrayed by the percentage of curriculum that was studied in a particular country, and the percentage of those curriculum items mastered on the TIMSS test. And I'm making up the numbers, I can't remember the numbers, but Singapore, you know, teaches, I don't know, I'm going to say 85% of the curriculum, and students master 79%. In the US, there's a similar gap. Internationally, it's something like, you know, teaching 75% and mastering 65%. Japan, teaches a relatively low proportion, like 65%, but the kids master like 80%. And what he makes of that, which I think is absolutely true because I've seen it happen in classrooms, is that if you teach in a problem-solving way, students are very accustomed to getting content that they've never gotten, and they can do it. So for example, when you introduce area of parallelogram, you show a parallelogram, you say, golly, anybody know anything? We know how to solve rectangles, but anybody know anything they could use to solve area of parallelogram? And the kids basically come up with ideas, some of them wrong, some of them right. And then they bring those ideas to the front, and the class has a discussion of why this works, why this doesn't work. And then several lessons later, they generalize the formula for area of parallelogram out of the student's own inquiry. So, and they do basically every new mathematical topic is introduced in that way. So when you learn to add fractions with unlike denominators, you know, you've got a half a liter of milk and a third of a liter of milk, how much do we have altogether? Kids try to solve it on their own, they bring the solutions up, and always someone has added a third and a half and gotten 2/5, and then the kids puzzle through. How could that be? You know, that's less than half when you've added a third and a half. So that's very much the nature of the instruction, and I honestly don't know if there are any other countries that teach in that way, but it's very relevant to the Common Core. You know, it's very much the habits of perseverance and explaining and critiquing and justifying and modeling problems that are, you know, at the heart of the Common Core, which is not accidental because the Common Core is another, I think, manifestation of a philosophy that's, you know, not so different from the earlier Einstein documents and work that Alan's done and, you know, Polia's work and so forth. It's kind of the same vision. So I think it's the questioning time up.
Thank you very much.